Bismillahirrahmanirrahim. Dear students, I think all of you will be fine. Respected participants, today we are going to start video lecture series of topological spaces. Today is lecture number 1 of topology. So we start the lecture with the word topology. We are going to start with the background of topology. Topology is called पॉइंट सेट टोपोलॉजी, इसको हम पॉइंट सेट टोपोलॉजी भी कहते हैं। टोपोलॉजी इज आल्सो कॉल्ड रबर ज्योमेट्री। द अदर नेम ऑफ टोपोलॉजी इज रबर ज्योमेट्री। टोपोलॉजी इज डिराइव्ड फ्रॉम ग्रीक वर्ड टोफोस which means position or location. The word topology is basically Greek derived tophos which is meaning position, जगह और लोकेशन या उसकी सराउंडिंग्स के बारे में है। फ्रेशे एंड हाउसडॉर्फ आर मेजर एक्सपोनेंट्स ऑफ टोपोलॉजी के टोपोलॉजी के दो बड़े मैथमेटिशियंस कौन से हैं? फ्रेशे एंड हाउसडॉर्फ हैं। हाउसडॉर्फ ने टाटू टोपोलॉजी भी दी थी, जिसका दूसरा नाम हम हाउसडॉर्फ टोपोलॉजी भी बोलते हैं। देन इज फ्लोरिशिंग ऑफ टोपोलॉजी। टोपोलॉजी flourished itself during the first decades of 20th century. After ending the 19th century and start of 20th century, first decades, the topology flourished itself. Now we move toward the definition of topological spaces. He is saying that let X, which is also called ground set, be a non-empty set. Let tau be a subset of capital X. Then tau is called a topology on X if it satisfies the following three conditions. Tau will become a topological space or topology if it satisfies the following three conditions. How many conditions? There are three conditions, which are, roughly speaking, they are called arbitrary union, number 2 finite intersection, and number 3 is about phi and capital X itself. Number 1, he is saying that union of any numbers of members of tau is again in tau. That is called arbitrary union. कि अगर आपके पास टा के कोई एलिमेंट्स हैं, आप उनमें से कुछ एलिमेंट्स को पिक करते हैं और उनका यूनियन लेते हैं, तो उनका रिजल्टेंट अगेन टा के अंदर होना चाहिए था। और ऐसा आप यूनियन ऑफ एनी नंबर ऑफ मेंबर ऑफ टा के कितने ही मेंबर आप पिक कर सकते हो, उस टा में से पिक कर लें, उनका यूनियन करेंगे, तो अगेन जो रिज़ल्ट आएगा वो टा का मेंबर होगा। नंबर 2, intersection of finite number of members of tau is again in tau. That is also called finite intersection. First one was about union and number 2 is about intersection, and which is finite. What he is saying, intersection of finite number of member of tau के टा के फाइनाइट नंबर ऑफ मेंबर की क्या करें, इंटरसेक्शन करें, तो उसका जो रिजल्टेंट होगा वो भी टा का मेंबर ही होगा। नाउ यहाँ पर ही इज़ आस्किंग अबाउट व्हाट finite intersection. It is not arbitrary intersection. So there is a chance, if you are going to discuss an infinite topology with infinite elements, then there may be issue if we take arbitrary intersection like arbitrary union. And number 3 is saying that phi and capital X are members of tau. Phi and X both are always member of tau. Then the order pair X star is called a topological space. कि फिर हमारे पास X star जो है वो एक topological space कहलाता है. After that we are going to define some important topological spaces and discuss them. Number one is discrete topology. Now what is discrete topology? The set of all possible subsets of capital X, ground set called power set of X, denoted as P of X. कि कैपिटल X नॉन एम्प्टी जो है उसके जितने भी पॉसिबल सबसेट्स बनते हैं उन तमाम को एक सेट में लिख दें तो वो उसका क्या बन जाता है, पावर सेट बन जाता है. Itself power set is a topology on capital X which is called discrete topology. कि जिसको हम किसका नाम देते हैं, discrete topology का नाम देते हैं. Important note is here, discrete topology is finest, strongest topology on a given set. A greatest, finest topology that can be made on a set is discrete topology. After that, we move towards an example of discrete topology. Let capital X is equal to 1 to 3. Then P of X, power set of X क्या होगा? You know power set of X का फार्मूला 2 power n है, where n is number of elements of capital X. Here number of capital X are 3, so 2 raised to the power 3 is 8. It means P of X contains 8 elements. So you can see that P of X contains 8 elements. This whole P of X is a topology on X which is called discrete topology. If you want to verify that whether it is a topology or not, then you will try the 3 conditions. Number 1 was arbitrary union. If you take any number of tau and take union, you will get any element out of these elements. If we discuss about intersection, if you take finite number of tau and then intersect them, you will get the answer from these 8. And definitely you can look phi and capital X are part of tau. So dear students, all 3 conditions of being topology are satisfied. So P of X, power set of X, is a topology which is discrete topology and which is finest and best topology of all that can be defined on capital X. So we move forward. After discrete topology, there is indiscrete topology. What is indiscrete topology? Indiscrete topology is totally different from discrete topology. In indiscrete topology, he is saying that if you consider only 2 elements in a set, the set containing phi and capital X consisting of only 2 sets is a topology on X called indiscrete topology. Indiscrete topology contains only 2 elements which are phi and capital X. Note, indiscrete topology is weakest, coarsest than all topological spaces that can be constructed on capital X. The topologies you may construct on capital X, out of these the weaker topology is indiscrete topology. So dear students, today we are stopping the lecture on this point. Inshallah, in next lecture we will move towards next example of important topological spaces and move forward. So thank you so much. अगर आपको चैनल अच्छा लगता है, समझ आती है, so kindly आपने लाइक एंड सब्सक्राइब लाजमी कर देना है। थैंक यू सो मच।